October 14th, 1943, 11:47 a.m. Schweinfurt, Germany. The acrid smell of cordite hung in the morning air as Hauptmann Klaus Weiler adjusted his oxygen mask and banked his Messerschmitt Bf 109 G6 into a climbing turn. The Daimler-Benz DB605 engine roaring at maximum continuous power of 1,475 horsepower. Through the armored glass of his canopy, he could see the massive formation of American B-17 flying fortresses approaching from the northwest, their aluminum fuselages glinting like scattered coins against the October sky, each one bristling with defensive machine guns and carrying nearly 5 tons of high-explosive ordnance toward the ball-bearing factories that kept the Reich's war machine turning. But today, something was different about the American escort fighters. Weiler had been flying combat missions over the Western Front since the summer of 1940, had witnessed the brutal mathematics of aerial warfare play out across 3 years of increasingly desperate fighting, and in all that time he had never seen anything quite like the massive, barrel-shaped fighters that now accompanied the flying fortresses into German airspace. These were not the nimble Supermarine Spitfires that the Royal Air Force had been sending over the Channel since 1940, nor were they the reliable but unremarkable Curtiss P-40 Warhawks that the Americans had fielded in North Africa and the Mediterranean theater throughout 1942 and early 1943. These new American fighters were enormous. "Mein Gott," crackled the voice of Oberleutnant Heinrich Baer through the radio static, his Focke-Wulf 190A8 maintaining formation 300 meters off Weiler's starboard wing. "Look at the size of those things. They're as big as medium bombers." The Republic P-47 Thunderbolt, as American intelligence reports would later confirm, weighed 17,500 pounds when fully loaded for combat operations, making it nearly twice as heavy as the Messerschmitt Bf 109 G6 that Weiler was flying, and substantially heavier than any single-engine fighter aircraft that had ever been mass-produced for frontline military service. Its Pratt & Whitney R2800 double wasp radial engine generated 2,535 horsepower at war emergency power settings, driving a 4-bladed Curtiss electric constant-speed propeller with a diameter of 13 feet and 6 inches through the increasingly thin air at altitudes exceeding 25,000 feet above sea level. But what truly distinguished the P-47 Thunderbolt from every other fighter aircraft in the world was not its size or its engine power, but rather the 8 Browning M2, 50 caliber machine guns mounted in its wings, each one capable of firing 850 rounds per minute of armor-piercing incendiary ammunition with a muzzle velocity of 2,910 feet per second and sufficient kinetic energy to penetrate the armored cockpits, fuel tanks, and engine blocks of German fighter aircraft from ranges exceeding 1,000 yards. It was, by any rational measure of firepower and destructive capability, completely absurd. No single-engine fighter in history had ever carried such devastating offensive armament, and the very concept seemed to violate fundamental principles of aircraft design that had governed military aviation since the Wright brothers first achieved powered flight at Kitty Hawk in December of 1903. Fighter aircraft were supposed to be fast, maneuverable, and lightweight, optimized for dogfighting at close range where pilot skill and aircraft agility determined the outcome of aerial combat encounters. Heavy armament meant heavy weight, which meant reduced performance in every other category that mattered for air-to-air combat effectiveness. At least, that had always been the conventional wisdom among aircraft designers and military aviation theorists on both sides of the Atlantic Ocean. From the Messerschmitt factories in Augsburg to the Supermarine Works in Southampton to the engineering departments at North American Aviation in Inglewood, California, where teams of mathematicians and aerodynamicists spent countless hours calculating optimal power-to-weight ratios and turning radius specifications for the next generation of interceptor fighters. "Those fat American pigs will never be able to turn with us," Weiler muttered into his radio microphone as he watched the P-47 Thunderbolts climbing steadily toward the bomber formation at an indicated airspeed of 350 miles per hour. "Look how slow they climb. We'll tear them apart." The mathematics of aerial combat seemed to support Weiler's confidence. His Messerschmitt Bf 109G6 had a wing loading of only 40.1 pounds per square foot and could execute a complete 360-degree turn in approximately 20 seconds at optimal altitude and airspeed, while the massive P-47 Thunderbolt carried a wing loading of 39.2 pounds per square foot, despite its enormous size and weight. A seemingly impossible figure that suggested either fundamental errors in American engineering calculations or revolutionary advances in aerodynamic design that German intelligence services had somehow failed to detect and analyze. But impossible or not, there they were, climbing inexorably toward the bomber formation with the steady, mechanical precision of industrial machinery, their pilots maintaining perfect formation discipline as flak bursts began to pepper the sky around them with black puffs of smoke and shrapnel, each aircraft carrying 3,400 rounds of 50 caliber ammunition and enough high-octane aviation gasoline to remain in combat for nearly 4 hours without refueling or returning to base. The industrial mathematics of American aircraft production were about to teach the Luftwaffe a lesson that no amount of tactical brilliance or individual pilot skill would be able to overcome. The impossible claim had been circulating through Luftwaffe intelligence reports since late August of 1943, when reconnaissance photographs from Allied airfields in England began showing massive concentrations of the new American fighter aircraft assembled in neat rows on freshly constructed concrete runways. Their distinctive razorback canopies and enormous radial engines, clearly visible even from the extreme altitudes required to avoid detection by Royal Air Force interceptors. According to these reports, which seemed so fantastical that many senior Luftwaffe officers dismissed them as obvious propaganda or deliberate misinformation, the Americans were planning to deploy more than 4,000 Republic P-47 Thunderbolts to the European theater of operations before the end of 1943. 4,000 single-engine fighter aircraft, each one weighing nearly 9 tons when fully loaded and carrying enough firepower to destroy an entire squadron of German interceptors in a single engagement. It was a number so staggering, so completely divorced from the material realities of wartime aircraft production, that it seemed to belong more in the realm of science fiction than military intelligence analysis. Amerikanische Märchen, laughed Oberst Johannes Steinhoff as he reviewed the latest intelligence estimates in his headquarters bunker beneath the Tempelhof airfield in Berlin. The concrete walls around him trembling slightly as Royal Air Force Lancaster bombers passed overhead at 20,000 feet, their Rolls-Royce Merlin engines creating a deep, throbbing vibration that had become the soundtrack of life in the German capital during the autumn of 1943. American fairy tales. Even the Americans are not stupid enough to waste their aluminum on such monsters. Steinhoff had commanded fighter units on the Eastern Front since Operation Barbarossa began in June of 1941, had witnessed firsthand the brutal efficiency with which German aircraft factories could convert raw materials into combat-ready interceptors when the survival of the Reich depended upon maximum production output. And he understood better than most officers in the Luftwaffe High Command exactly what it required to manufacture, equip, train, and deploy a single fighter squadron for frontline combat operations against experienced enemy pilots flying proven aircraft designs. The mathematics were unforgiving and absolute. Each Messerschmitt Bf 109G6 required approximately 500 man-hours of skilled labor to complete. From the initial forming of aluminum sheet metal components to the final installation of radio equipment and armament systems, not including the additional time required to manufacture the Daimler-Benz DB605 engine, the VDM constant speed propeller, the electrical systems, the hydraulic components, the oxygen equipment, the gun sight, the armor plating, and the hundreds of smaller parts and assemblies that transformed raw materials into a functional weapon of war. German aircraft factories were currently producing approximately 1,200 single-engine fighters per month across all production lines, a figure that represented the absolute maximum output achievable given current allocations of aluminum, steel, rubber, electrical components, skilled machinists, assembly workers, and the countless other resources required for large-scale aircraft manufacturing under wartime conditions. and the Germans had been preparing for this war since 1933. The Americans, by contrast, had entered the conflict less than 2 years earlier, following the attack on Pearl Harbor in December of 1941, which meant that their aircraft industry had been operating under full wartime production schedules for barely 24 months. When these intelligence reports began appearing on the desks of Luftwaffe planning officers in Berlin and Munich, even assuming that American industrial capacity exceeded German capacity by a factor of 2 or 3 to 1, which seemed optimistic given the disruptions caused by converting civilian manufacturing facilities to military production, there was simply no way that any nation on Earth could produce 4,000 heavy fighter aircraft in such a compressed time frame. Besides, added Hauptmann Egon Meyer, who had just returned from a combat tour over the Western Front and was now serving as a tactical advisor to the Reich Air Ministry. Have you seen the performance specifications for this so-called Thunderbolt? Maximum speed of 433 miles per hour at 25,000 feet, service ceiling of 42,000 feet, range of 1 through 30 miles with external fuel tanks. These numbers are propaganda fantasies designed to intimidate our pilots. Mayer pulled a manila folder from his briefcase and spread several reconnaissance photographs across Steinhoff's desk, each one showing P-47 Thunderbolts in various stages of assembly at Republic Aviation's manufacturing facility in Farmingdale, Sohoy, New York, which American censors had somehow failed to obscure completely despite strict security protocols governing all military-related industrial photography during wartime. "Look at this monstrosity," Mayer continued, pointing to a partially completed P-47 fuselage that had been photographed from directly above, revealing the massive internal structure required to mount 8 50-caliber machine guns in the aircraft's wings. "It carries more ammunition than some of our light bombers. The weight alone should make it incapable of combat maneuvering." But the photographs told a different story than the one Mayer was constructing from his preconceptions about fighter aircraft design. The P-47 Thunderbolt's wing structure, visible in several of the reconnaissance images, incorporated advanced engineering techniques that German aircraft designers had never attempted on such a large scale, including stressed skin construction methods that distributed structural loads more efficiently than traditional framework approaches, allowing the aircraft to carry extraordinary amounts of armament and fuel without sacrificing structural integrity or flight performance characteristics. The mathematics of American engineering were about to prove that conventional wisdom could be overcome by unconventional industrial capacity. The multiple independent sources began arriving at Luftwaffe intelligence headquarters throughout September of 1943, each one confirming details that seemed increasingly impossible to reconcile with existing understanding of aircraft manufacturing capabilities and strategic resource allocation during total warfare conditions. Flight Lieutenant James Morrison of the Royal Air Force's No. 61C Squadron had been shot down over occupied France on September 12th and interrogated at Dulag Luft, the Luftwaffe's primary interrogation center for captured Allied airmen, where he provided detailed descriptions of P-47 Thunderbolt operations that he had witnessed during escort missions over the Low Countries and northwestern Germany. According to Morrison's testimony, which was recorded verbatim by Hauptmann Hans Scharf, the Luftwaffe's most skilled interrogator, American P-47 squadrons were arriving in England at a rate of approximately 1 complete fighter group every 10 days, with each group consisting of 3 squadrons of 25 aircraft plus operational reserves. "The Yanks have got bloody great hangars full of the things," Morrison had said during his 3rd day of interrogation, his voice carrying the exhaustion and disorientation common among recently captured airmen. "Row after row of them, all painted in that olive drab and gray camouflage scheme, with ground crews working round the clock to get them operational." Morrison's account was corroborated by intercepted radio transmissions from American fighter pilots operating over occupied Europe, many of whom used insufficiently encrypted communication channels that allowed German signal intelligence units to monitor their tactical communications and extract valuable information about aircraft performance, armament effectiveness, and operational procedures. On September 18th, Obergefreiter Wilhelm Hoffmann of the 2nd Company, 26th Panzer Grenadier Regiment, had been positioned in an observation post near Antwerp when a formation of P-47 Thunderbolts attacked a German supply convoy moving along the main coastal highway from Brussels to Amsterdam. Hoffmann's written report, filed through normal military channels and eventually forwarded to Luftwaffe intelligence analysts, described the devastating effectiveness of concentrated 50-caliber machine gun fire against armored vehicles, personnel carriers, fuel trucks, and ammunition trailers. The American fighters came in at low altitude from the northwest, Hoffmann wrote, flying in formations of 4 aircraft each, and when they opened fire, it was like watching industrial machinery at work. The sound was not like machine guns at all, but rather like enormous canvas being torn apart by invisible hands, and the effect on our vehicles was immediate and complete destruction. Swiss journalist Heinrich Weber, reporting for the Neue Zürcher Zeitung from his position as a neutral observer in London, had filed several dispatches during late September that provided detailed descriptions of American fighter aircraft operations from British airfields, including specific references to the massive logistical infrastructure required to support P-47 Thunderbolt squadrons in combat. Each American fighter group requires approximately 400 tons of aviation gasoline per week, Weber reported, plus 50 tons of ammunition, 20 tons of replacement parts, and sufficient maintenance equipment to service engines that generate more horsepower than the largest bomber aircraft were producing just 2 years ago. Weber's figures align closely with captured German intelligence estimates of American fuel consumption patterns, which suggested that P-47 Thunderbolt operations were consuming high-octane aviation gasoline at rates that would have exhausted Germany's entire strategic petroleum reserves within 6 months of sustained combat operations. Even more disturbing were the reports from General Major Adolf Galland, who had personally flown combat missions against P-47 formations during October of 1943 and observed their performance characteristics under actual battle conditions. Galland's after-action reports, distributed to all Luftwaffe fighter group commanders, described tactical encounters that seemed to violate fundamental principles of aerial combat as they had been understood since the First World War. The American pilots are not attempting to engage in traditional dogfighting, Galland wrote in his confidential assessment dated October 20, 1943. Instead, they use their aircraft's superior diving speed and firepower to execute high-speed attack passes, then climb back to altitude using their powerful engines and supercharging systems. They are fighting an entirely different kind of war than the one we have been preparing for. The captured diary of Captain Robert S. Johnson, a P-47 pilot with the 56th Fighter Group who had been forced to bail out over occupied Netherlands on October 8th, contained detailed entries describing American tactical doctrine and training procedures that emphasize the Thunderbolt's advantages in high-altitude performance and long-range escort missions rather than traditional air superiority dogfighting. "We're not flying Spitfires," Johnson had written. "We're flying airborne battleships. 850 calibers can destroy anything that flies, and our engines can take us higher and farther than any fighter the Germans have ever built. The mathematics are on our side." The mathematics Johnson referenced were about to transform the aerial warfare over occupied Europe into an industrial process rather than a test of individual pilot skill and aircraft agility. The technical specifications of the Republic P-47 Thunderbolt represented a revolution in fighter aircraft engineering that German designers had neither anticipated nor understood. Incorporating manufacturing techniques and design philosophies that transformed aerial warfare from an artisanal craft, practiced by individual pilots, into an industrial process governed by mathematical certainties rather than tactical improvisation. At the heart of this transformation was the Pratt & Whitney R2800 double wasp radial engine, a mechanical marvel consisting of 18 cylinders arranged in 2 rows of 9 cylinders each, with a total displacement of 2,804 cubic inches and the capability to generate 2,535 horsepower at war emergency power settings when equipped with a General Electric B-Series turbo-supercharger that could maintain sea-level engine performance at altitudes exceeding 30,000 feet above sea level. The engine itself weighed 20,60 pounds when fully equipped with all accessories: propeller hub, reduction gearing of WIS, and cooling systems, which was more than the empty weight of many German fighter aircraft. Yet it could operate continuously at maximum power for periods exceeding 4 hours without mechanical failure or performance degradation. The turbo-supercharger system that enabled this high-altitude performance represented one of the most sophisticated pieces of mechanical engineering ever installed in a production fighter aircraft. Incorporating a turbine wheel driven by exhaust gases that could spin at rotational speeds exceeding 21,000 revolutions per minute, while maintaining precise pressure regulation through an automatic wastegate system that adjusted boost pressure according to altitude and throttle position. This system allowed the P-47 to maintain combat power at altitudes where German fighters experienced significant performance reductions due to the decreasing density of atmospheric oxygen available for combustion in their engines. The armament installation consisted of 8 Browning M250 caliber machine guns, 4 mounted in each wing panel, with each gun capable of firing 850 rounds per minute of armor-piercing incendiary ammunition weighing 1.7 ounces per round and achieving muzzle velocities of 2,910 feet per second when fired from the standard 36-inch barrel length used in aircraft installations. The total ammunition load carried by a fully equipped P-47 Thunderbolt was 3,400 rounds, distributed among the 8 guns with 425 rounds per gun, representing a total projectile weight of 347.5 pounds, traveling at combined muzzle velocities that generated kinetic energy levels equivalent to approximately 45,000 foot-pounds per second when all 8 guns fired simultaneously. The wing structure required to support this armament load incorporated stressed skin construction techniques developed by Republic Aviation's engineering team under the direction of Alexander Kartveli, a Georgian-born aeronautical engineer who had immigrated to the United States in 1927 and spent the following 15 years developing advanced aircraft design methodologies that challenged conventional approaches to fighter aircraft construction. Kartveli's wing design distributed structural loads through the aluminum skin itself, rather than relying solely on internal framework members, allowing the wing to carry extraordinary loads while maintaining aerodynamic efficiency and structural integrity under the extreme gravitational forces generated during high-speed combat maneuvering. The fuel system consisted of a 305-gallon internal fuel tank located behind the pilot's seat, plus provisions for mounting 2 150-gallon external drop tanks beneath the wings, providing a total fuel capacity of 605 gallons when configured for maximum range escort missions. This fuel load, combined with the engine's specific fuel consumption rate of 0.45 pounds per horsepower per hour at cruise power settings, enabled the P-47 to remain airborne for combat missions lasting up to 8 hours and covering distances exceeding 1,800 miles when equipped with external tanks. The cockpit environment incorporated pressurization systems, oxygen equipment, radio communication gear, and navigation instruments that allowed pilots to operate effectively at altitudes where the atmospheric pressure was less than 1/4 of sea level pressure and ambient temperatures could reach -67 degrees Fahrenheit. The pilot sat behind 5 inches of laminated armor glass and was protected by steel armor plating weighing 287 pounds that could stop rifle-caliber ammunition and shell fragments from anti-aircraft artillery. Every system, every component, every engineering decision reflected an approach to fighter aircraft design that prioritized industrial mass production over artisanal craftsmanship, standardized components over customized solutions, and overwhelming firepower over elegant maneuverability. It was the mathematics of American industrial capacity translated into aluminum, steel, and high-octane aviation gasoline, designed not to win individual dogfights but to destroy entire air forces through the systematic application of superior numbers and superior firepower. It was the mathematics of inevitability. The central set piece began at 12:23 p.m. on October 14th, 1943, when Hauptmann Klaus Weiler led his swarm of 4 Messerschmitt Bf 109G6 fighters into a diving attack against a formation of P-47 Thunderbolts, escorting B-17 Flying Fortresses toward the ball. Bearing factories at Schweinfurt, the autumn sunlight glinting off polished aluminum as 16 German fighters descended from 28,000 feet in a perfectly coordinated assault that represented 3 years of hard-learned tactical doctrine refined through countless aerial battles over the skies of Europe. Weiler had executed the same attack pattern dozens of times during his combat career, diving at maximum speed to achieve surprise, opening fire at close range to ensure maximum hit probability, then using the accumulated kinetic energy from the dive to climb back to altitude for another attack pass before enemy fighters could respond effectively. It was a proven technique that had destroyed hundreds of Allied aircraft since the beginning of the war, and there was no reason to believe that these oversized American fighters would present any greater challenge than the Spitfires and Hurricanes that German pilots had been shooting down with methodical efficiency since 1940. The mathematics of aerial combat seemed to favor the attacking force, as they always had when lighter. More maneuverable aircraft engaged heavier, less agile opponents under conditions that emphasize speed and surprise over sustained maneuvering combat. But as Weiler's formation approached firing range, something unprecedented happened. The P-47 Thunderbolts did not attempt to turn and engage in traditional dogfighting maneuvers, nor did they break formation and scatter to avoid the German attack, as British pilots had learned to do when confronted by superior numbers of German fighters always diving from higher altitude. Instead, the American pilots maintained their escort formation and began firing their 850 caliber machine guns at extreme range, creating a wall of projectiles that filled the airspace between the two formations, with 6,800 rounds per minute of armor-piercing incendiary ammunition, traveling at nearly 3,000 feet per second. The effect was unlike anything Weiler had ever experienced in aerial combat. His Messerschmitt Bf 109G6, which had seemed so solid and reliable during 3 years of combat operations, began disintegrating around him as .50 caliber projectiles tore through aluminum skin, severed control cables, punctured fuel lines, and shattered engine components with devastating efficiency. The armor-piercing rounds, each one weighing 1.7 ounces and carrying sufficient kinetic energy to penetrate 3/4 of an inch of hardened steel at 500 yards, turned the lightweight construction of German fighter aircraft into a fatal liability rather than an advantage. Within 12 seconds of initial contact, 3 of Weiler's 4 aircraft had been destroyed completely. Their pilots either killed instantly by direct hits to their cockpits or forced to bail out of aircraft that had become unflyable due to catastrophic structural damage caused by multiple 50 caliber hits to critical flight control systems. Weiler himself managed to survive the initial exchange only because his aircraft happened to be positioned slightly behind and below the main formation when the P-47s opened fire. But as he attempted to disengage and climb back to altitude, he discovered that the American fighters could match his rate of climb despite their enormous weight, their turbo-supercharged engines generating sufficient power to maintain combat effectiveness at altitudes where his Daimler-Benz DB605 was already operating near the limits of its performance envelope. The pursuing P-47 Thunderbolts did not attempt to engage in turning combat, but instead used their superior diving speed and firepower to execute repeated high-speed attack passes, climbing back to altitude after each engagement and positioning themselves for another devastating firing pass whenever Weiler attempted to maneuver defensively. It was not aerial combat as German pilots understood the concept, but rather systematic destruction carried out with industrial efficiency. Each attack pass designed to inflict maximum damage with minimum risk to the attacking aircraft. The mathematical application of superior firepower and engine performance against opponents who had been trained to fight an entirely different kind of war. After 18 minutes of continuous pursuit and repeated attack passes, Weiler's Messerschmitt finally succumbed to accumulated battle damage when a burst of 50 caliber fire severed his elevator control cables and punctured his main fuel tank, forcing him to bail out over occupied territory and parachute to Earth while his aircraft spun toward the ground in an uncontrollable death spiral. As he descended beneath his silk parachute, watching the P-47 Thunderbolts resume their escort positions and continue toward Schweinfurt with mechanical precision, Weiler understood that he had just witnessed the future of aerial warfare, a future in which individual pilot skill and aircraft agility would matter far less than industrial capacity and overwhelming firepower systematically applied through superior numbers and superior technology. The age of the fighter ace was ending. Replaced by the mathematics of mass production and concentrated firepower, the systemic scale expansion of American P-47 Thunderbolt production during the final months of 1943 revealed industrial mathematics so overwhelming that they transformed the strategic calculus of aerial warfare across the entire European theater of operations, creating logistical realities that German intelligence analysts initially dismissed as statistical impossibilities generated by Allied propaganda ministries rather than accurate assessments of actual manufacturing output from American aircraft factories. Republic Aviation Corporation's manufacturing facility in Farmingdale, New York, was producing 664 P-47 Thunderbolts per month by November of 1943, representing one complete fighter aircraft rolling off the assembly line every 67 minutes, during round-the-clock production schedules that operated 24 hours per day, 7 days per week, employing 2,300 workers across 3 shifts and consuming 847 tons of aluminum alloy, 156 tons of steel, 89 tons of copper, 12 tons of rubber, and 31,000 gallons of specialized lubricants, hydraulic fluids, and protective coatings every single week. The Pratt & Whitney R2800 double WASP engines that powered these aircraft were being manufactured at a rate of down 200 units per month across multiple production facilities in East Hartford, Connecticut, Kansas City, Missouri, and Nashville, Tennessee, each engine requiring 2,147 precision-machined components manufactured to tolerances measured in thousandths of an inch and assembled by skilled machinists working with specialized tooling that had been designed specifically for mass production of high-performance aircraft engines under wartime conditions. The 50 caliber ammunition required to arm these aircraft was being produced at Frankfurt Arsenal in Philadelphia at a rate of 3 million rounds per month, each projectile manufactured from brass cartridge cases, lead cores, steel penetrator tips, and incendiary compounds that were precisely measured, assembled, and quality tested according to specifications that ensured consistent ballistic performance across temperature ranges from minus 65 degrees Fahrenheit to plus 160 degrees Fahrenheit. High-octane aviation gasoline production had increased from 40 million gallons per month in January of 1942 to 485 million gallons per month by October of 1943, representing a 12-fold increase in productive capacity achieved through the construction of 47 new petroleum refineries specifically designed for aviation fuel production, plus the conversion of 183 existing civilian refineries to military production schedules that operated at maximum capacity with minimal maintenance downtime. The aluminum required for P-47 production was being extracted from bauxite ore at a rate of 9 million tons per year, processed through electrolytic reduction facilities powered by hydroelectric dams that generated 14.7 billion kilowatt-hours of electricity annually, enough electrical power to illuminate every city in Germany for 6 months, while simultaneously operating the industrial machinery required to transform raw aluminum into aircraft components through stamping, forming, welding, and precision machining operations. Transport aircraft were delivering completed P-47 Thunderbolts to combat theaters at a rate of 89 aircraft per week, each one flown across the North Atlantic via staging bases in Newfoundland, Greenland, and Iceland by ferry pilots who made the 3,500-mile journey in stages, refueling at predetermined intervals and maintaining radio contact with navigation stations that provided weather updates and course corrections throughout the transoceanic flight. The logistical infrastructure required to support P-47 operations in the European theater included 1,247 specialized maintenance technicians, 3,891 ground crew personnel, 156 million rounds of 50 caliber ammunition stored in climate-controlled bunkers, 23.4 million gallons of high-octane aviation gasoline distributed through underground pipeline systems, 45 to 600 replacement parts ranging from spark plugs to engine blocks, and 2,300 tons of specialized maintenance equipment transported from American factories to British airfields via convoy routes that traverse submarine-infested waters of the North Atlantic. Radio equipment alone required 67,000 vacuum tubes per month, each one hand-assembled by skilled technicians working in temperature-controlled facilities where humidity, dust levels, and electrical interference were precisely regulated to ensure consistent performance of communication and navigation systems that operated across frequency ranges from 200 kilohertz to 156 megahertz. The total industrial effort represented by P-47 Thunderbolt production and deployment consumed approximately 2.3% of America's total manufacturing capacity during 1943, including 847,000 skilled workers, 234 manufacturing facilities, research and development laboratories, and supply chains that extended from bauxite mines in Arkansas to rubber plantations in Brazil to precision instrument manufacturers in Massachusetts, all coordinated through industrial planning processes that treated warfare as an engineering problem solvable through systematic application of superior productive capacity. It was an avalanche of numbers that represented the transformation of American industrial might into aerial dominance through mathematical certainties rather than tactical brilliance, the systematic conversion of raw materials into combat effectiveness on a scale that German planners had never imagined possible and could not hope to match with their own industrial resources under wartime conditions. The enemy realization moment came on November 26, 1943, when Oberst Johannes Steinhoff stood in the operations bunker beneath Tempelhof Airfield and watched American P-47 Thunderbolts destroy an entire Gruppe of German interceptors with such mechanical efficiency that the engagement resembled industrial machinery processing raw materials rather than aerial combat between opposing fighter pilots. Through the periscope that emerged above ground level, Steinhoff observed 48 P-47 Thunderbolts maintaining perfect formation discipline as they escorted a stream of B-24 Liberator bombers toward targets in central Berlin, their turbo-supercharged engines generating vapor trails at 25,000 feet that stretched across the November sky like parallel chalk lines drawn by an enormous compass. The American formation flew with mathematical precision, each aircraft maintaining exact spacing and altitude intervals that suggested training procedures and operational doctrine far more sophisticated than anything German intelligence analysts had anticipated. When Hauptmann Egon Meyer led 16 Messerschmitt Bf 109G6 fighters in a climbing attack from the southeast, attempting to use superior rate of climb and tactical surprise to achieve firing position against the bomber formation. The P-47 escorts responded with devastating effectiveness that transformed what should have been an even engagement between experienced fighter pilots into systematic annihilation carried out with industrial thoroughness. The American fighters did not break formation or engage in individual dogfighting maneuvers, but instead maintained their escort positions while directing concentrated firepower against the attacking German aircraft. Their 8 50-caliber machine guns creating intersecting fields of fire that filled cubic kilometers of airspace with 27 200 rounds per minute of armor-piercing incendiary ammunition, traveling at velocities that turned aluminum aircraft structures into shredded metal fragments within seconds of initial contact. "Mein Gott in Himmel," whispered Steinhoff as he watched Meyer's aircraft disintegrate under the concentrated fire of 4 P-47 Thunderbolts. The Messerschmitt's wings separating from the fuselage in a shower of sparks and debris that glinted like scattered coins against the gray November clouds. They are not fighting. They are manufacturing destruction. That within 4 minutes and 37 seconds, all 16 German fighters had been either destroyed or so severely damaged that their pilots were forced to disengage and attempt emergency landings at the nearest available airfields, while the P-47 formation continued toward Berlin without having lost a single aircraft or even breaking formation discipline during the engagement. But it was what Steinhoff observed next that truly revealed the scope of American industrial capacity and the mathematical inevitability of German defeat in the air war over Europe. As the P-47 Thunderbolts completed their escort mission and turned toward their home bases in England, They jettisoned their external fuel tanks over occupied territory, allowing 150-gallon aluminum drop tanks worth approximately $240 each to fall into German-controlled airspace where they would be lost forever, representing a casual disposal of resources that would have supplied a German fighter squadron for an entire week of combat operations. The sight of 48 external fuel tanks tumbling toward Earth like oversized confetti struck Steinhoff with the force of a physical blow. Not because of the immediate tactical implications, but because of what it revealed about the fundamental mathematical relationship between American productive capacity and German material limitations under total warfare conditions. Each discarded fuel tank represented 47 pounds of aluminum alloy, 12 pounds of specialized fittings and valves, 2 pounds of rubber sealing compounds, and 156 precision-manufactured components that German aircraft factories would have required 18 man-hours of skilled labor to duplicate, assuming they could obtain the raw materials through increasingly disrupted supply chains that stretched across a European continent under constant Allied bombardment. The Americans were discarding 11,520's worth of aircraft components every time a single P-47 squadron completed an escort mission, treating aluminum and precision manufacturing as expendable resources that could be replaced faster than they could be consumed, even under the most intensive combat conditions imaginable. "They have so much," Steinhoff murmured, his voice barely audible above the rumble of approaching Royal Air Force bombers beginning their nightly assault on the German capital. "So much that they throw it away without thinking." When, for the first time since joining the Luftwaffe in 1935, Steinhoff understood that Germany was not fighting an enemy air force, but rather an entire industrial civilization that had transformed warfare into a manufacturing process, where victory would be determined not by pilot skill or aircraft performance, but by the mathematical application of superior productive capacity against opponents who simply could not match the scale of American material abundance. The realization struck him with the cold certainty of an engineering calculation. Germany could not win a war of industrial attrition against an enemy that discarded more resources in a single mission than German factories could produce in a month of maximum output under ideal conditions. The mathematics were as clear and unforgiving as the laws of physics themselves. The closing thesis emerged with mathematical certainty during the final weeks of 1943, as Luftwaffe combat reports documented the systematic destruction of German fighter units across the Western Front, through the relentless application of American industrial capacity rather than superior tactics or individual pilot skill. Transforming aerial warfare from an art practice by skilled craftsmen into a manufacturing process governed by production statistics and resource allocation, rather than courage and flying ability. By December 31, 1943, the United States Army Air Forces had deployed 2,847 Republic P-47 Thunderbolts to the European theater of operations, representing more single-engine fighter aircraft than Germany had been able to produce across all aircraft types during the entire year of 1943, while American factories continued to increase production rates that would deliver an additional 4,758 P-47s during the first 6 months of 1944, creating numerical superiority so overwhelming that German resistance became mathematically impossible rather than merely tactically difficult. The industrial mathematics that governed this transformation were brutally simple and absolutely decisive. American aircraft factories were producing P-47 Thunderbolts faster than German pilots could destroy them. Even under the most optimistic assumptions about combat effectiveness and pilot survival rates. While German aircraft production remained constrained by material shortages, labor limitations, and manufacturing facilities that operated under constant threat of Allied bombardment. Each P-47 Thunderbolt shot down over occupied Europe was replaced by 7 new aircraft arriving from American production lines within 14 days of its destruction, while each German fighter pilot killed in action required 18 months of training and 240 flight hours to replace, assuming that adequate fuel supplies, training aircraft, and experienced instructors remained available for pilot training programs that increasingly competed with frontline operations for critically scarce aviation gasoline and maintenance resources. The German aircraft industry, operating at maximum possible output under wartime conditions, could produce approximately 39,000 aircraft of all types during 1943, including bombers, transport aircraft, reconnaissance planes, and training aircraft as well as fighters, while American factories manufactured 85,946 military aircraft during the same period, representing productive capacity that exceeded German output by a factor of 2.2 to 1 across all categories of military aviation. But the true measure of American industrial dominance lay not in total aircraft production, but in the systematic application of concentrated firepower through standardized weapon systems that transformed individual aircraft into components of a larger industrial process designed to achieve air superiority through mathematical certainty rather than tactical innovation. The 850 caliber machine guns mounted in each P-47 Thunderbolt represented firepower equivalent to an entire squadron of German fighters armed with traditional rifle caliber weapons, while the 3,400 rounds of ammunition carried by each aircraft provided sustained firing capability that exceeded the total ammunition load of 4 Messerschmitt Bf 109G6 fighters combined, creating tactical situations where single American aircraft could engage multiple German opponents with reasonable expectation of success. This was not tactics, but the industrial inevitability of superior productive capacity systematically applied through technological advantages that German industry could neither match nor counter with existing resources under wartime conditions that increasingly favored nations capable of transforming entire civilian economies into military manufacturing systems operating at maximum efficiency for sustained periods. The mathematics of aerial warfare had been permanently altered by American industrial methods that treated combat aircraft as mass-produced commodities rather than individually crafted weapons. Pilots as trained operators of standardized equipment rather than artisanal craftsmen practicing ancient skills. And air superiority as an engineering problem solvable through systematic application of superior numbers and superior firepower, rather than superior training or superior aircraft design. German pilots had laughed at the P-47 Thunderbolt because they understood aerial combat as individual contests between skilled pilots flying agile aircraft in close-range engagements where maneuverability and pilot ability determined outcomes. But the Americans had redefined aerial warfare as an industrial process where victory belonged to the side capable of delivering the greatest amount of firepower with the greatest degree of reliability over the longest possible period of time. As 1943 ended and 1944 began, Hauptmann Klaus Weiler sat in a prisoner of war camp in England and watched through barbed wire as formations of P-47 Thunderbolts took off from nearby airfields with the mechanical regularity of factory production lines, their Pratt & Whitney engines generating the same deep, throbbing sound that had filled the October sky over Schweinfurt when he first encountered the massive American fighters that had seemed too large and too heavy to be effective instruments of aerial warfare. Now he understood that size and weight had been advantages rather than limitations, that the Americans had built their fighters like industrial machinery because they intended to use them like industrial machinery. Systematically and relentlessly and with mathematical precision that reduced aerial combat to statistical certainties rather than individual contests of skill and courage. The acrid smell of high-octane aviation gasoline drifted across the prisoner of war camp as another formation of Thunderbolts climbed towards the European continent, carrying 272,000 rounds of 50 caliber ammunition toward targets where German pilots waited with aircraft that could not match their firepower, could not match their numbers, and could not match the industrial capacity that had created them. It was the mathematics of inevitability, as precise and unforgiving as the laws of physics themselves,